Hi everyone, in this video we are going to discuss about a linear regression analysis problems by the hand calculations. Let's take a quick look at this example. We have the number of fires and the number of acres burned are as follows. The first row represents the number of the fires X, and the second row represents the number of the acres or the Y value. The first part is to draw the scatter plot. You can draw the scatter plot on the XY axis by hand, but I'm going to use Excel in this case just so we can get an accurate graph. So to plot the scatter plot on Excel, all you do now is you enter the X column on the left side and the Y column, the values on the right hand side. And now we just simply highlight that, and we go to insert, and we go to the charts here, and you can click on this one, insert the scatter, and just click on the first one. Okay, so the first one, so this one right here is your scatter plot. Now we can also cut the distance here to zoom it in only around this portion so that we can easily see the relationship between the X and the Y axis. And we can do that by selecting the X axis. So you can select the X axis, click on the X axis here, and then right click, format the axis. And for the X axis, at the moment we have the mean value to be 0, but we can start that from 40 instead of 0, and you can close it. And now the scatter plot, it looks a little bit better. You can see the X and the Y, right? The X and the Y and other dots here. So that is the first part of the questions. The second part, they ask you, are they linearly related? Okay. Well, if you are using Excel, we can check for the linear correlation coefficient to see if we have a value that is close to 1 or -1, then the two variables, they are linearly related to each other. And we can find that correlation coefficient by using the command. So press equal, and then we use CORREL. So this is the correlation coefficient. Okay, it will return the correlation coefficient between the two data sets. And you open the parentheses, and in the first one we enter the X value, and then comma, we enter, or we drag the whole Y column, and we close it, and we hit enter, and the value is 0.77. This is not too close to 1, but we can say that this is a moderate case. It is in the middle. Okay, if you get a value that is super close to 1, then we have a strong linear relationship between the Y and the X variables. But this value is 0.77. It's not super close to 1, but it is still indicating that we do have some kinds of relationship between the X and the Y's, and they can be modeled using a linear equation. But it is not a perfect one. But still, we still could be able to find a linear line that is going through these points in the direction of these data points here. Alright, now we can go to the next part. Find the linear regression line. So how do we do that? Alright, so for any linear regression analysis, we have the formula y equal a plus bx. This is the y-intercept and b is the slope. And the formula to find a and b are here. This notation is the sum, so we take the sum of all the y value. This is the sum of all the x squared value, and we multiply together. The n here is the number of the data points that we have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 set of data points, so n is equal to 8 in this case. So we have n equal 8 in this case. Now, in order to find all of these values, we should construct a table because it will organize everything and makes it looks nicer. Okay, so I have x column, I have the y column, and then I have the xy column, and I also have the x square column, and I also have the y square column, and I just divide them and make sure that you put all the x and y from the table. So we have 72, 69, we have 72, we have 69, we have 58, 47. So we have 58, 47, and 84, 62. We have 84, 62, and 57, 45. 57, and then 45. And then I would fill out the value for y as well. And the reason that I have another column for x, y, x squared, y squared, because I do see those expressions from the formula to find a and b. Okay. Alright. So now x, y is just the product or the multiplication between x and y. So we have 72 multiplied to 62. Then I have 4, 4, 6, and then 4. 4, 4, 6, 4. And next one I have 69 multiplied to 42, which gives me 2898. And then I do the same thing here. I have 58 multiplied to 19. I get 1102. And then you would do the same thing for the rest and use these values. And then next columns, we are looking for the x squared. So we take whatever the x here, we multiply by itself. So 72 squared, or 72 multiplied by 72, that gives me 5184. And then I have 69 squared, 69 multiplied to 69, that is 4761. And you would do the same thing for each of the x here to get all of the value below. And the last column we would do the same thing, but then we take the y value square. So we have 62 square, which will give me 3844, and then we repeat the same thing for the rest of these value square and these values. Alright, and now in the last row we should find the sum of these columns. So in this column, the first one, I want to find the sum. This is the summation notation. I want to find the sum of the x. That means I'm adding everything here. 72 add 69 add 58 all the way to 45, and I should get 494. And then the same thing, I would find the sum of the y column. So I add all of these values together and I get 260. And then here I have the product xy. So I'm looking for the sum of the product xy. I'm adding all of these values together and I get 17,285. And then here we have the sum of all the x square, right? And it will give you the summation of the entire column. And we have 31,692. And then lastly, we have the sum of all the y square. So we have the y square column. We add them up all together, and we will 10,596. All right, so now we have everything ready that we can plug in the formula to find the answer for A and B. Okay, so here we have the formula for A. We have the sum of the y. The sum of the y, we have 260. And then we have the sum of the x squared, which is this value, 31,692, minus the sum of x, which is 494, and the sum of xy, which is 17,285, and then divide by n. We have a total of n to be 8, because we have 8 set 1, 2, 3, 4, 5, 6, 7, 8 data points. So 8 all the pairs, right? So n is 8, and the sum of the x squared, which is this one, 31,692, and subtract the sum of all the x, which is all the x here, 494, and then keep the square outside. And if you plug that in your calculator, you should be able to negative 31.46. And the next one, we are looking for B. So we have n is again 8, and the sum of all the xy, which is this number 17285, and then minus the sum of the x, which is 494, and then the sum of the y, which is 260, right? 260, and then dividing by n again is 8, and the sum of the x squared, is 31,692, and minus the sum of x and the square outside. Be careful here. This is the sum of x, which is this value, and then the square, we keep it outside. And if you plug that in all of the numbers here in a calculator, you should be able to 1.036 if you round it to 3 decimal places. Alright, so now we have the equation. The equation is a plus bx, right? A plus bx, and the a value is right here, minus 31.46 plus b is right here, 1.036, and then the x. So this is the linear regression model for the A data points that we have here from the list, and we can use this one to make the prediction for any value of x. And in fact, we are asked to find the number of acres burned when we have 60 fires. Remember, fires is the value of x. So what happens if we have 60 fires? So when x is equal to 60, what is the value of y? Looking on the chart here, we don't see the value when x is equal to 60. We have 69, we have 57, 62, but we don't have the value for 60. So we need to make the prediction when the x value is 60. And that's why we need to find a model, an equation, so that we can make the prediction. So now, the y value when x is equal to 60. I just use the equation, the model we just found, and anywhere I see the x, I simply make the substitution of 60 because X is the number of the fires now is 60. And then I use the calculator to carry out this calculation. And that should give me 30.7. And this is the value for acre. So 30.7 acres burned when we have 60 fires. And that is how we calculate the linear regression line completely by hand.